Have you ever stopped to wonder why apples don't fly? Why do they always insist on falling straight down from the tree? The answer lies within the intriguing concept of gravity. Gravity, in simple terms, is the force that pulls objects towards each other. It's the invisible string that keeps our feet firmly planted on the ground and the moon in its celestial dance around the earth. But how does this force work? And how fast does it make things fall? To understand this, we delve into the concept of the acceleration of gravity, often symbolized as g. Think of a ball being dropped from a certain height. The speed at which this ball falls, or more specifically, how fast it picks up speed, is the acceleration due to gravity. On Earth, this speed is approximately 9.81 meters per second, every second. The intriguing part is that the exact value of g isn't a constant. It varies depending on where you are on Earth, the altitude, and the nature of the surface beneath. For instance, g is slightly higher at the poles than at the equator, a phenomenon caused by the Earth's rotation. If you're standing at a high altitude, g decreases slightly due to the reduced mass of the Earth above that point. Now, how do we calculate g? A formula comes to our aid. It's written as g equals gm divided by r squared. Here, g is the acceleration of gravity, g is the gravitational constant, m is the mass of the planet, and r is the distance from the object to the center of the planet. Let's take an example. The acceleration of gravity on the surface of the moon is about 0.166 g. This is because the moon's mass is much smaller than that of Earth. So, to sum it up, gravity is the force that pulls objects towards each other, and the acceleration of gravity, g, is how quickly an object speeds up as it falls. The value of g varies depending on location, altitude, and the nature of the surface. It's calculated using the formula g equals gm divided by r squared. But remember, gravity doesn't just make apples fall from trees. It shapes the universe, governs the motion of the planets, and even bends the path of light. It's a fundamental force that holds our world, and indeed the entire universe, together. It's gravity that keeps us grounded in every sense of the word.